Hey, so today in this video, we'll see how Omega network works and how it passes the information or data between processes and memory. So first of all, we will take an 8x8 Omega network, and first thing we need to do is to convert. Let's say these are processors and these are my memory. Okay, so first of all, what I need to do is to just convert it down to the binary. So this is going to be 0, 0, 0. This is going to be 0, 0, 1. This is going to be 0, 0. Then I'm going to be 1, 1, 1, 1. So this is just a short method to do it. 1, 1, 0, 1, 0, 0. And then again 0, 1. And then again I have to put 1, 1 and 0, 1. Okay, so the same thing goes here. So let's just do it quickly because we need to use this binary to get the direction of the data. And let's just get over with it real quick. Uh-oh, I just messed it up. This is just a 1. This is 1, 1, 0. This is 1, 1, 1. Okay. So now what we need to do is to find a way to our processor P5 to memory M2. So how are we going to do that? And we can see that this is our memory 2 and this is our processor 5. So basically to do that, we need to check for the binary of our M2. And before moving on to that, I want you to know that inside each cell, we have some specific zeros and ones. So we need to go over through that. Okay, so these cells that I'm talking about, let's build them first. So I'm just going to say that the upper one is going to say 0, and then it's 1. Then it's going to be 0, then it's going to be 1. So 0, 0, 1, 1. And then it's 0, 0, 1, 1. So work it in everyone. So let's just quickly build them. These are inside almost everyone. This is going to be 0, this is going to be 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Let me just keep typing it for a while and then you can just skip the video to that part where I'm done. Okay, 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 I'm pretty much done. Okay, get that into our main area. So I want to jump from P5 to M2. So basically I need to see what is the binary of the M2. So the binary of the M2 is 0, 1, 0, as we can see here. And what's the binary of the P5? The P5 got 1, 0, 1. So basically what we are trying to do is to get inside here. So we're gonna get directly inside this thing. So we are here now, okay? So now we're gonna check for the binaries. The first one is actually 0. And where we are standing inside the memory is actually 1. So what we need to do is to take a shift and go to the 0. So now once we are at the 0th location, we're gonna take the path from here up to here. So here, now what we need to do is to actually check for the second one. So if we check for the second one, it's 1. And where we are present, it's actually 1. So we're just going to pass through it straight. And then we find the next path. And here we go. We're down to that path again. And then we're going to check for the last one. And last one is also 0. So where we are actually on the 0. So we're going to get straight. And that's it. We have reached our position of the 2. So that's how you can move your processor data to your memory inside your distributed system. And this is how this thing works. And basically just you need to remember what is that thing that the binary of your memory is only going to be used for the inner switching and not for the outside. Once you are at the edge, like I switched from 1 to 0, now I'm at the edge. So I'm going to take the route which is predefined for me. So it's going to be pretty simple. And then I'm going to check for the next letter once I'm inside the next switch. So this is how it's done. And I hope that this is pretty much clear. And let's just say bye for now.